An Internet Service Provider, ISP, is a company that provides individuals and organizations with access to the Internet and other related services. An ISP has the equipment and access to the telecommunications lines necessary to operate a point of presence on the Internet in the geographic area it serves. ISPs provide their customers with access to the Internet and also offer additional services such as email, domain registration, and web hosting. ISPs may also provide different types of Internet connections, such as cable or fiber optic. Connections may also be available in the form of high-speed broadband or non-broadband connections. An ISP is sometimes referred to as an Internet Access Provider or simply an Internet Service Provider. ISP is also an acronym for Independent Service Provider to describe a service provider that is a separate company from a telephone company. How do ISPs work? ISPs are connected to one or more high-speed Internet lines. Larger ISPs have their own high-speed leased lines, allowing them to be less dependent on telecommunications services and provide better service to their customers. ISPs also maintain thousands of servers in data centers, with the number of servers depending on their Internet service area. These large data centers manage all customer traffic. Some ISPs are also connected to large backbone routing centers. ISPs are divided into three levels. Tier 1 ISP, these ISPs have the largest global reach and own enough physical network lines to handle the majority of traffic themselves. They also negotiate with other Tier 1 networks to allow free traffic to pass through to other Tier 1 providers. Tier 1 ISPs typically sell network access to Tier 2 ISPs. Tier 2 ISP, these ISPs have a regional or national reach and are service providers that connect Tier 1 and Tier 3 ISPs. They must purchase access to larger Tier 1 networks but are on par with other Tier 2 Internet service providers. Tier 2 networks focus on residential and business customers. Tier 3 ISP, these ISPs connect customers to the Internet through another ISP's network. Tier 3 ISPs use and pay higher tier ISPs to access Internet services. They focus on providing Internet access to local businesses and consumers. ISPs and the different types of services. ISPs offer the following Internet services. Cable. This service uses coaxial cable, the same type of cable used to transmit television. Cable offers download speeds of 50 to 1000 Mbps and upload speeds of 25 to 50 Mbps. During peak times, especially in the evenings, cable internet speeds can fluctuate greatly. Fiber optic. Fiber optic internet transmits data over fiber optic cables, allowing for much higher speeds compared to cable or DSL, digital subscriber line. Fiber optic offers download speeds of 100 to 1000 Mbps and upload speeds of 50 to 500 Mbps. Fiber optic is good for online gamers and other heavy internet users. DSL. DSL connects users to the internet through their phone line. It is widely used but is slowly being replaced by more reliable broadband connections such as fiber optics. DSL offers download speeds of 50 to 350 Mbps and upload speeds of 5 to 40 Mbps. Upload speeds range from 2.4 to 50 Mbps. DSL is a good option for users in rural areas and for those who surf the internet, do office work from home and use TV streaming services with a few devices at the same time. Satellite. Internet access via satellite works through the use of communications satellites. Ground stations transmit internet data in the form of radio waves to and from satellites, which are often in geostationary orbit, and to more distant ground stations. Satellite internet is comparatively slow with download speeds of 12 to 100 Mbps and upload speeds of up to 3 Mbps, but is often still the fastest option for users in remote areas. According to the provider, the Starlink network with satellites in low Earth orbit achieves download speeds of 40 to 220 Mbps and 8 to 25 Mbps for upload. With Starlink, communication takes place directly via a special satellite antenna. All of the satellite offerings mentioned struggle with comparatively high latency. Most major internet providers have the first three of the services mentioned in their program. How to choose the right internet provider. When choosing an internet provider, you should consider several factors, including coverage area, which providers offer service in your area. If you live in a rural area, your options may be limited. Type of services offered, in addition to cable, fiber optic, DSL or satellite, does the ISP also offer online security? Free email access? Website hosting? Make sure the ISP's offerings meet your needs. Download and upload speeds. Do you want to play games online or work from home and hold video conferences? Both require different service levels. For example, streaming 4K video requires a bandwidth of at least 25 Mbps. Pricing. Does the ISP offer services such as internet, phone, and TV in a package, and if so, does the combination save money? Is there a data cap? What about equipment costs? Is the router included in the price or does it have to be purchased or rented monthly? What is the minimum contract term? Is there an additional setup fee? Evaluate consumer satisfaction. Check unbiased sources for provider reviews. An Internet Service Provider, ISP, is an organization that provides myriad services related to accessing, using, managing, or participating in the Internet. ISPs can be organized in various forms, such as commercial, community-owned, non-profit, or otherwise privately owned. Internet services typically provided by ISPs can include Internet access, Internet transit, domain name registration, web hosting, and co-location. The Internet, originally ARPANET, was developed as a network between government research laboratories and participating departments of universities. Other companies and organizations joined by direct connection to the backbone, or by arrangements through other connected companies, sometimes using dial-up tools such as UUCP. By the late 1980s, a process was set in place towards public, commercial use of the Internet. Some restrictions were removed by 1991, shortly after the introduction of the World Wide Web. During the 1980s, online service providers such as CompuServe, Prodigy, and America Online, AOL, began to offer limited capabilities to access the Internet, such as email interchange, but full access to the Internet was not readily available to the general public. In 1989, the first Internet service providers, companies offering the public direct access to the Internet for a monthly fee, were established in Australia and the United States. In Brookline, Massachusetts, the World became the first commercial ISP in the U.S. Its first customer was served in November 1989. These companies generally offered dial-up connections, using the public telephone network to provide last-mile connections to their customers. The barriers to entry for dial-up ISPs were low and many providers emerged. However, cable television companies and the telephone carriers already had wired connections to their customers and could offer Internet connections at much higher speeds than dial-up using broadband technology such as cable modems and digital subscriber line, DSL. As a result, these companies often became the dominant ISPs in their service areas, and what was once a highly competitive ISP market became effectively a monopoly or duopoly in countries with a commercial telecommunications market, such as the United States. In 1995, ENSFNet was decommissioned, removing the last restrictions on the use of the Internet to carry commercial traffic, and network access points were created to allow peering arrangements between commercial ISPs. On April 23, 2014, the U.S. Federal Communications Commission, FCC, was reported to be considering a new rule permitting ISPs to offer content providers a faster track to send content, thus reversing their earlier net neutrality position. A possible solution to net neutrality concerns may be municipal broadband, according to Professor Susan Crawford, a legal and technology expert at Harvard Law School. On May 15, 2014, the FCC decided to consider two options regarding Internet services. First, permit fast and slow broadband lanes, thereby compromising net neutrality, and second, reclassify broadband as a telecommunications service, thereby preserving net neutrality. On November 10, 2014, President Barack Obama recommended that the FCC reclassify broadband internet service as a telecommunications service in order to preserve net neutrality. On January 16, 2015, Republicans presented legislation, in the form of a U.S. Congress H.R. discussion draft bill, that makes concessions to net neutrality but prohibits the FCC from accomplishing the goal or enacting any further regulation affecting internet service providers. On January 31, 2015, AP News reported that the FCC will present the notion of applying, with some caveats, Title II, Common Carrier, of the Communications Act of 1934 to the Internet in a vote expected on February 26, 2015. Adoption of this notion would reclassify Internet service from one of information to one of the telecommunications and, according to Tom Wheeler, chairman of the FCC, ensure net neutrality. The FCC was expected to enforce net neutrality in its vote, according to the New York Times. On February 26, 2015, the FCC ruled in favor of net neutrality by adopting Title II, Common Carrier, of the Communications Act of 1934 and Section 706 in the Telecommunications Act of 1996 to the Internet. The FCC chairman, Tom Wheeler, commented, "This is no more a plan to regulate the Internet than the First Amendment is a plan to regulate free speech. They both stand for the same concept." On March 12, 2015, the FCC released the specific details of the net neutrality rules. On April 13, 2015, the FCC published the final rule on its new net neutrality regulations. These rules went into effect on June 12, 2015. Upon becoming FCC chairman in April 2017, Ajit Pai proposed an end to net neutrality, awaiting votes from the Commission. On November 21, 2017, Pai announced that a vote will be held by FCC members on December 14, 2017 on whether to repeal the policy. On June 11, 2018, the repeal of the FCC's network neutrality rules took effect. Since December 31, 2021, the Affordable Connectivity Program has given households in the U.S. at or below 200% of the federal poverty guidelines or households which meet a number of other criteria an up to $30 per month discount toward Internet service, or up to $75 per month on certain tribal lands. Access provider ISPs provide Internet access, employing a range of technologies to connect users to their network. Available technologies have ranged from computer modems with acoustic couplers to telephone lines, to television cable, CATV, Wi-Fi, and fiber optics. For users and small businesses, traditional options include copper wires to provide dial-up, DSL, typically asymmetric digital subscriber line, ADSL, cable modem, or integrated services digital network, ISDN, typically basic rate interface. Using fiber optics to end users is called fiber to the home or similar names. Customers with more demanding requirements, such as medium to large businesses, or other ISPs, can use higher speed DSL, such as single-pair high-speed digital subscriber line, Ethernet, Metropolitan Ethernet, Gigabit Ethernet, Frame Relay, ISDN Primary Rate Interface, ATM, Asynchronous Transfer Mode, and Synchronous Optical Networking, SONET. Wireless access is another option, including cellular and satellite Internet access. Access providers may have an MPLS, multi-protocol label switching, or formerly a SONET backbone network, and have a ring or mesh network topology in their core network. The networks run by access providers can be considered wide area networks. ISPs can have access networks, aggregation networks / aggregation layers / distribution layers / edge routers / metro networks and a core network / backbone network. Each subsequent network handles more traffic than the last. Mobile service providers also have similar networks. A mailbox provider is an organization that provides services for hosting electronic mail domains with access to storage for mailboxes. It provides email servers to send, receive, accept, and store email for end users or other organizations. Many mailbox providers are also access providers, while others are not, example Gmail, Yahoo Mail, Outlook.com, AOL Mail, PO Box. The definition given in RFC 6650 covers email hosting services, as well as the relevant department of companies, universities, organizations, groups, and individuals that manage their mail servers themselves. The task is typically accomplished by implementing Simple Mail Transfer Protocol, SMTP, and possibly providing access to messages through Internet Message Access Protocol, IMAP, the Post Office Protocol, webmail, or a proprietary protocol. Internet hosting services provide email, web hosting, or online storage services. Other services include virtual server, cloud services, or physical server operation. Just as their customers pay them for Internet access, ISPs themselves pay upstream ISPs for Internet access. An upstream ISP such as a Tier 2 or Tier 1 ISP usually has a larger network than the contracting ISP or is able to provide the contracting ISP with access to parts of the Internet the contracting ISP by itself has no access to. In the simplest case, a single connection is established to an upstream ISP and is used to transmit data to or from areas of the Internet beyond the home network. This mode of interconnection is often cascaded multiple times until reaching a Tier 1 carrier. In reality, the situation is often more complex. ISPs with more than one point of presence, POP, may have separate connections to an upstream ISP at multiple POPs, or they may be customers of multiple upstream ISPs and may have connections to each one of them at one or more point of presence. Transit ISPs provide large amounts of bandwidth for connecting hosting ISPs and access ISPs. Border Gateway Protocol is used by routers to connect to other networks, which are identified by their autonomous system number. Tier 2 ISPs depend on Tier 1 ISPs and often have their own networks, but must pay for transit or Internet access to Tier 1 ISPs, but may peer or send transit without paying, to other Tier 2 ISPs. Tier 3 ISPs do not engage in peering and only purchase transit from Tier 2 and Tier 1 ISPs, and often specialize in offering Internet service to end customers such as businesses and individuals. Some organizations act as their own ISPs and purchase transit directly from a Tier 1 ISP. Transit ISPs may use OTN, Optical Transport Network, or SDH/SONET, Synchronous Digital Hierarchy/Synchronous Optical Networking, with DWDM, Dense Wavelength Division Multiplexing, for transmitting data over optical fiber. For transmissions in a metro area such as a city and for large customers such as data centers, special pluggable modules in routers, conforming to standards such as CFP, QSFP-DD, OSFP, 400ZR or OpenZR+ may be used alongside DWDM, and many vendors have proprietary offerings. Long-haul networks transport data across longer distances than metro networks, such as through submarine cables, or connecting several metropolitan networks. Optical line systems and packet optical transport systems can also be used for data transmission. Ultra-long-haul transmission transports data over distances of over 1,500 kilometers. A virtual ISP, VISP, is an operation that purchases services from another ISP, sometimes called a wholesale ISP in this context, which allow the VISP's customers to access the Internet using services and infrastructure owned and operated by the wholesale ISP. VISPs resemble mobile virtual network operators and competitive local exchange carriers for voice communications. Free ISPs are Internet service providers that provide service free of charge. Many free ISPs display advertisements while the user is connected, like commercial television. In a sense, they are selling the user's attention to the advertiser. Other free ISPs, sometimes called free nets, are run on a non-profit basis, usually with volunteer staff. A wireless internet service provider, WISP, is an internet service provider with a network based on wireless networking. Technology may include commonplace Wi-Fi wireless mesh networking, or proprietary equipment designed to operate over open 900 MHz, 2.4 GHz, 4.9, 5.2, 5.4, 5.7, and 5.8 GHz bands or licensed frequencies such as 2.5 GHz, EBS/BRS, 3.65 GHz, NN, and in the UHF band, including the MMDS frequency band, and LMDS. It is hypothesized that the vast divide between broadband connection in rural and urban areas is partially caused by a lack of competition between ISPs in rural areas, where there exists a market typically controlled by just one provider. A lack of competition problematically causes subscription rates to rise disproportionately with the quality of service in rural areas, causing broadband connection to be unaffordable for some, even when the infrastructure supports service in a given area. In contrast, consumers in urban areas typically benefit from lower rates and higher quality of broadband services, not only due to more advanced infrastructure but also the healthy economic competition caused by having several ISPs in a given area. How the difference in competition levels has potentially negatively affected the innovation and development of infrastructure in specific rural areas remains a question. The exploration and answers developed to the question could provide guidance for possible interventions and solutions meant to remedy the digital divide between rural and urban connectivity. Altnets, portmanteau of alternative network provider, are localized broadband networks, typically formed as an alternative to monopolistic internet service providers within a region. ISPs may engage in peering, where multiple ISPs interconnect at peering points or internet exchange points, IXPs, allowing routing of data between each network, without charging one another for the data transmitted, data that would otherwise have passed through a third upstream ISP, incurring charges from the upstream ISP. ISPs requiring no upstream and having only customers, end customers or peer ISPs, are called Tier 1 ISPs. Network hardware, software, and specifications, as well as the expertise of network management personnel, are important in ensuring that data follows the most efficient route, and upstream connections work reliably. A trade-off between cost and efficiency is possible. Tier 1 ISPs are also interconnected with a mesh network topology. Internet exchange points, IXPs, are public locations where several networks are connected to each other. Public peering is done at IXPs, while private peering can be done with direct links between networks. Internet service providers in many countries are legally required, example via Communications Assistance for Law Enforcement Act, CALIA, in the US, to allow law enforcement agencies to monitor some or all of the information transmitted by the ISP, or even store the browsing history of users to allow government access if needed, e.g. via the Investigatory Powers Act 2016 in the United Kingdom. Furthermore, in some countries ISPs are subject to monitoring by intelligence agencies. In the US, a controversial national security agency program known as PRISM provides for broad monitoring of Internet users' traffic and has raised concerns about potential violation of the privacy protections in the Fourth Amendment to the United States Constitution. Modern ISPs integrate a wide array of surveillance and packet sniffing equipment into their networks, which then feeds the data to law enforcement/intelligence networks, such as DCSNet in the United States, or SORM in Russia, allowing monitoring of Internet traffic in real time. Thank you for watching this video.